Good morning, everyone. So today we'll continue with the Terraform topic. In the last session, we had started the Terraform theory part, wherein we discussed what is Terraform. So Terraform is an ISC tool, and we have cloud formation, which is a similar tool in AWS. Then we discussed why Terraform is required. Then we discussed Terraform templates, Terraform modules, and then we discussed the Terraform commands. What is Terraform state file? And then we discussed how we can store the state file. So state file can be stored in S3 bucket as a remote backend, and we'll be using DynamoDB in order to log the state file. That is what we'll be doing. Then we discussed the three blocks in that can be used in template, which is resource block, data block, and locals block. And the remaining blocks we will discuss today. So we have discussed resource block, data block, and locals block. So we will discuss the remaining blocks today. What are the important blocks that are used in the templates? So this is the template. Inside the template, you will be using multiple blocks. So yesterday we discussed resource block, data block, uh, and locals block. So today we will discuss provider block. Then we will discuss variables block, variable block, output block, provisioner block, and the backend block. And the module block. Provider variable, output block, module block, backend, and provisioner. So these are the other blocks that we will be using in the Terraform template. So we will discuss these blocks one by one. What are these blocks used for? So let us first discuss what is a provider block. So provider block is used to define the cloud that you are using. Okay, so you can work across, as I told you, you can work across multiple clouds. You can work for AWS. You will be working for with Azure Cloud, or you will be working with Google Cloud, GCP. So these clouds needs to be defined in the provider block. So if you're working with AWS Cloud, you have to define it with the provider. Likewise, Azure and Google block will be defined. Azure and Google Cloud will be defined in the provider block. So the code will be written like this. The block will be written like provider followed by the cloud name. Let's say, for example, AWS. And then inside, you can define other parameters like region. So whatever region that you're working, for example, US East 1. And then you have to define the, if required, you can also define the profile. Profile equal to, let's say, my AWS profile. This is how the provider block will look like. Okay, so these are the Terraform blocks. This is a summary of the block, and that provider block will look like this. So this is a very simple block, but this is where you have to define the cloud that you will be working on. So currently, let's say we will be working with AWS. So we have to define provider AWS, followed by the region name. And if required, this is optional. If you want, you can define it in the profile block, or this configuration can be done via IAM rule. So this we will see later. So using profile block, with the help of profile block, you can work with multiple clouds in a single code. So let's say if you're working with multiple clouds, you can define it in a single code like this. Like for example, provider Azure, then region is let's say uh, East US one. Okay, like I need to write it like this, East US one, and then again you can define the profile equal to let's say my Azure profile. So profile is wherein you will be storing the credentials of different clouds, right? So for example, you will be storing the access key and secret key for AWS inside this my AWS profile. You can store the credentials for Azure in my Azure profile. And similarly, if you're working with other cloud like Google, you have to define provider Google. And then you can define the region equal to US East 1. And here, instead of using profile, you have to use credentials. So profile is not supported in Google. You have to use credentials. It's a my Google profile like this and close the bracket. So using Terraform, you can work across multiple clouds, right, at the same time. And if you want to do it, if you want to work across multiple clouds, you need to make use of this profile. But if you are working on a single cloud, let's say for example, if you're working only with AWS, if you're working only with AWS, then this profile block is optional. Okay, you don't need to define the profile block. You need to do the configuration of your credentials within your local machine. So how to do that? That we will be seeing practically. Okay, how to configure your local machine to use your AWS account. That we will be seeing later. But just remember that the profile block will be used when you are working with multiple clouds, right, like this. This is where you will be storing the credentials of different clouds. So this is another use case of Terraform wherein you can work with multiple clouds at the same time. Okay, in the same code, you can work with multiple clouds. Now let's move ahead and discuss variable block. Now what is a variable? Variable is a repetitive value. Okay, so something that repeats multiple times in the code. So let's say for example, you are defining the owner equal to Alexa. Now this value is will repeat multiple times in the code, right? So rather than defining the owner, you can just mention it at a variable like var.owner like this, and the owner variable you can define it only once. So rather than defining every time, rather than defining the owner in the entire code, and or rather than hard coding it in the code, you can just use a variable that is var owner, and this variable can be defined using the variable block. So variable owner, and then you have to define the type of variable. So like this is a type is string, and you have to define the default value. So the default value is equal to Alexa like this. So this is how you can define the variables in Terraform. So it is used to define the input variables. Okay, so you can just mention the variable name. Where you have to define the variable variable block. So this is the variable block followed by the variable name. Okay, what variable name you have given, and what is the default value. So this is where you have to define the default value. Now this type is string. Right? This is a string. String is nothing but it is a combination of alpha numeric characters. That is what we call it as a string. So what are the types of variables? These types we will be discussing now. What are the types of variables that are used in Terraform? Now here I've given an example wherein uh, variabilized instance type. So rather than hard coding the instance type T2 micro every time in the code, I have given it as a variable instance type. Now let's say if I want to change the instance type, instead of using T2 micro, if I want to change it to T2 medium, I can simply do it once, and wherever the value is used, wherever the variable is used, that will get replaced. So that is a very good use case of variable, that you have to just define the variable once inside the variable block, and the value will be inherited like in multiple places wherever you have defined that variable in the Terraform code. Now let us understand what are the different types of variables. So basically they are divided into two types. One is keywords and second is constructors. So this type over here, the type of variable is divided into two categories. One is called as a keyword, second is called as a constructors. And in the keywords also they are further divided into three categories. One is called as a string, which I have given an example already. Second is called as the number, wherein you will be defining only the number. And third is called as a boolean. So boolean means true or false. Correct, 1, 2, 3, 4, 5. And here the string means combination of alphanumerical characters. Or let's say as I defined Alexa, or let's say T2 micro is another example of a string. Right? So these keywords are further divided into three categories. One is called as a string, another is called as the number, and the third is called as the boolean. So if you are defining values like true or false, you have to use boolean. If you are defining a number, you have to use the type equal to number. And if you are using a string, you have to define type equal to string. So here in this case, what we have done is we have defined the type equal to string. Now moving ahead with constructors. Constructors are divided into three types. One is called as the list, another is called as the map, and the third type is called as a set. Okay, these are the three types in constructors: list, map, and set. So list is nothing but it is a list of values. For example, let's say list of environments or a list of different items. So this is called as a list. For example, it will be written like this. Or let's say UAT, or let me write in small UAT, comma, SIT, comma, production, like this. So this is called as a list of values, right? So this is just a list of values. Second is called as a map. Map is key and value, combination of key and value. So let's say environment is equal to UAT, like this. Or you can define it like this: type equal to environment, right? And value equal to UAT, like this. You can just put it in the inverted quotes. This value has to be in the inverted quotes like this. So this is called as a map. And the third category is called as a set. So set is one uh, one variable will store multiple values. For example, env is equal to type equal to env, and value equal to ult, and this will be put in the square brackets instead of curly braces. So here the value has multiple, we can say, inputs. I have given another example wherein, like, let's say list is a list of cities, Mumbai, Pune, Delhi. Map is type equal to city, name equal to Mumbai, right? And in the set it will be city equal to type is city, name equal to Mumbai, right? And here one thing to correct here, set will be put in curly braces. Map will also be put in curly braces, except the list will be, you have to enter it in the square brackets. This is the only change here. So the list will be defined in square brackets, and rest of the things will be defined in the curly braces. So these are the six types of variables. Right? So string, number, boolean, list, map, and set. So this way we'll be using, for example, yesterday we had defined tags, if you remember, tags equal to name equal to Alexa. If you remember, I had given a tag right yesterday, and comma env equal to prod. So this is called as a set. Now yesterday what we did is we just wrote it in a next line like this, just to make it easier to read. We had written it like this. But mostly tags is a set of values. Right? So the tag can have multiple values. It can have name of Alexa. It can define the production. It can define ownership, etc. So this will have multiple values like this. Okay, so this is the another example of set. So the set will be written like this. So the tag itself will have multiple values. Okay, so this is the types of variables, or we can say is the variable data types. Okay. Now let us discuss what are the ways to define the variables. How can we define the variables in Terraform? So it can be defined in multiple ways, or how to use the variables in Terraform. So the first way is by using the default file. So we have a file called as variables.tf, and this file consists of the default variables. So what will Terraform will do is it will always fetch the default variables from this file, which is called as a variables.tf. Okay, so this is a this is a file which consists of the default variables. Now the next type is called as a terraform.tf. Terraform.tf vars. So this is a standard file which is used to define the overwriting variables. So let's say you want to overwrite the default variables. You can do it with the help of this terraform.tf var files. So these are overwriting variables. These are the variables which can be easily overwritten. So these are the overwriting variables. So what this terraform.tf apps file will do is it will it will overwrite the default variables. So whatever variable that you have defined over here, just for example, let's say here you have defined the variable type equal to t2 dot micro, and then later what you did is you created a terraform.tf var file, and in that you defined m2 dot large. Then what Terraform will do is it will consider this one. So this will always have the top priority. So terraform.tf var files will always have the priority over the default variables. If you don't define anything in this Terraform.tf files, default variables will be considered. Okay, that is why it is called as a default. But if you want to override the default variable, this can be easily overwritten with the help of Terraform.tf files. Now this is a standard file that needs to be used. Okay, this is the name how it is written. Okay, overwriting variables are written or are defined in the file called as Terraform.tf files. But in case if you want to use a different name, you can do it. Let's say for example, I want to use a another name .tf. You can use it like this. But only thing is like you have to while running the command you have to mention the file name wherein let's say you are applying the Terraform commands. So Terraform apply hyphen var hyphen file is equal to another name .tf, right? So this can become quite confusing. I'm just telling you just for your information. If required, you can use a custom name as well. But if you are using a custom name, that then every time while applying, you have to mention that variable custom variable name like this while applying the Terraform apply command or while using the Terraform apply command. So we will not do this. Instead, we will use the standard file that is provided by Terraform. This is just for your information. In case if you ask me in an interview, what if I want to change this file name? You can do it. Only thing is that while running the Terraform command, you have to use the Terraform apply hyphen var file. You have to mention that file name while applying the Terraform command. So these are the two ways that I have explained. Now there is a third way wherein you can define the variables on the go. Rather than creating the variables, mentioning the variables inside the files, you can define the variables on the go with the help of the CLI. Like while applying only, you can define the variables using the CLI. So this is the third way. So this is quite similar to that I mentioned here. Hyphen var file equal to. Here you have to just define hyphen variable equal to variable name and variable value. For example, the command will look like this: Terraform apply hyphen var is equal to type equal to t2 dot micro. So this is how you have to define the variables on the go. So again, this can be quite challenging to use. So we will not prefer using this CLI or this renaming the other file. We will use this variables.tf and terraform.tf files. Another way is called as using the environment variables, env. You can set the environment variables. You can set the environment variable. So there is a command which is used like set extf underscore var. So the variable name, for example, type equal to t2 dot micro. So this you can define it in the CLI. So this will set an environment variable. Wherever there is a type t2 micro, it will be considered. Okay, it will be automatically applied. So that is how you can define it as an environment variable as well. But as I told you, we will be preferring only these two types, variables and Terraform.tf files. So these are the standard names how they are written. So do not change the file name. Okay, so this is how the file names are given. Terraform will only consider the files as per the file names. Okay, so it is variables.tf, don't forget, and it is terraform.tf vars, okay, plural. In both the types, the plural is used, right? Variables.tf and terraform.tf vars. So we will be using these two types only. We will be using these two files only for defining the default variables and the overwriting variables. So this we will discuss in practical. So this is all about variables, variable block. So we discussed the variable block, we discussed the types of variables and how to define the variables or how to use the variables in your Terraform code. Now let us move ahead and discuss the third block, that is the output block. Output block is used to display the output after the Terraform is applied. After the Terraform is applied, if you want to display some output, then you can make use of this output block. So let's say, for example, you have run the Terraform apply command, and an EC2 instance has been created. Okay, so this Terraform apply command, what it did, it created an EC2 instance. Now, if you want to get the public IP or private IP of this EC2 instance, let's say you want to get the public IP, or again you have to go to your AWS console and get the public IP. Right? You have to log into your AWS and get the public IP. So that can become quite challenging, right? Because the EC2 is not yet created. So you will not get the public IP in advance. You will get that public IP after the EC2 instances get created. So after you run the Terraform apply command, EC2 instance will get created. And after EC2 instance is created, then only public IP will get generated. Now, if you want to get the public IP, you have to log in back to your AWS account. And that is what we don't want to do. We want to avoid login to our AWS account. We want to do it everything by code. There you can make use of this output block. So here, let's say you have created an EC2 instance. You can just define the variable, output variable, and then you have to define the value. Okay, so let me just show you an example. For example, I have defined the resource block here. Resource, let's say AWS underscore instance, and let's say my EC2, open the bracket, and then I will define the AMI. Let's say AMI equal to whatever AMI ID that I have, 12345, and then type. Let's say type is t2.micro. Okay, close the brackets, and then I can make use of this output block. So output block will always start with output followed by the output variable. Let's say my public IP. You can give any name, or you can just give my, okay, that is fine, my public IP followed by the value. What is the value of it? So value is equal to, you have to take the name of this EC2 instance name, like this. Simplest way is this. Remove the quotes from here and just add a dot public underscore IP, like this. Let me just verify it. Okay, that is correct. So this, what will it will do is, output block, it will store the value of this public IP. This public IP value will be stored inside a variable called as my public IP, like this. It will store the value like my public IP, and whatever public IP that is generated of that EC2 instance. Let's say it is like this, 22.11.13.14.12, something like this. So this value will be stored inside this my public IP, and after you apply the code, you will get an output of the public IP like this. It will be displayed on your screen. Okay, in the output screen, you will get the public IP. So that is where output will come into picture. Right? So this plays a very important role if you want to fetch some values after the resources are created. Or let's say you want to pick up the private IP, you want to pick up the DNS name, or you want to pick up the ID of your EC2 instance, or you want to pick up the security ID, security group ID. Then in that case, you can make use of this output block. And again, you can make use of this output block to put that value in some other resource. Like, so let's say you have created an EC2 instance, you will get a public IP. You want to put that public IP into some different, let's say EC2 instance, another EC2 instance, that can also be done with the help of output block. So that is the function of output block. It is used to display the output after the code is executed, right? So this resources will be created. After the resources are created, if you want to pick up some values, then you can do it with the help of output block. So if you want to pick up some important information like public IP, private IP, endpoint, DNS name, or let's say if you're using static IPs, so all this information can be fetched with the help of output block. Now the next block is the module block, right? So yesterday we have defined modules. So what are modules? Modules are where you can shorten your long Terraform code. Okay, so let's say you have a Terraform code. You have written a Terraform code, and it is quite a very big code. It is a very big file. In order to shorten the file, you can make use of the Terraform modules. So what Terraform module will do is you can organize your file into smaller files wherein you can define the main value variables, input files, output files, or output variables. Then you can just bifurcate your bigger playbook into smaller playbook, smaller structured playbook, and that is what we call it as modules, right? That is what we discussed yesterday. Now, how do we use the module block? So let's say I have defined the modules like this. So I have created a folder. So I have created a folder with the name modules. Inside this folder, I have created another folder or a subfolder with the name EC2. Inside this folder, I have created another subfolder. I will give the name as EC2. And inside this directory, inside this EC2 folder, I have created multiple files. Right? So this is, let's say, main.tf file. This is variable.tf file. This is input.tf file. This is output.tf file and another terraform.tf var files. So I can place multiple files like this. Now, how do you make use of this module block? Okay, how do I call these files? So let me give the names as well. This is main.tf file. Then now this is variables.tf file. You can also create provider.tf file, which consists of the provider block. So you can bifurcate them as per the blocks. Then output.tf file, right? These are all the blocks as well, right? Now, in order to call this modules, you have to write module block, module, followed by the name that you want to give, any custom name. Open the bracket, and you have to define the path. You have to define the source. The source is equal to in the current directory inside modules folder, right? So in the current directory modules folder, you have to go inside EC2, right? So this is the source. Or you can give a name instead, like let's say my EC2 module. You can give any name over here. So this is how you can call the module block. So module blocks are used to call the modules. If you're using modules in your Terraform code and you want to call those modules, you will be using the module block like this. So you can define the custom name and the path. Okay, you have to define the path. So in the current directory, inside modules folder, and within modules folder, we have another folder called as EC2. So what this module will do is it will call out that module. So it is used to call multiple modules. Okay, and let's say if you're using another module with a name VPC, you can call it uh, in the same way. Okay, so this is how you will be defining the module block. And here in the modules, you can create multiple folders, right? So this is how it will be created. Here you can create another folder with the name VPC. Again, you can create another folder with another name. You want to create another resource. Let's say you want to create S3 resource. Everything can be structured with the help of modules like this. And each folder will have its independent files, right? Each and every folder will have its related files. So VPC will have files related to VPC. creating of VPC. S3 will have files related to S3 and so on. So this is how modules are created. They are just simply created into a directory structure and they are called in this way. Right? So you have to define the module and you have to define the source. Moving ahead, let us discuss the next important block, which is called as the backend block. So yesterday I told you that uh, if you don't want to store your state file locally, you can store it in a storage service provided by AWS, which is called as S3 bucket. Right? So I told you that state file can be securely stored in a backend using S3 bucket. So in order to define that backend, we need to use the backend module. Backend block. So this backend block is used to define your backend. So as an example, we will be using AWS S3. So if you want to store your state file in the backend, then you have to create a backend block like this. So it will be written as Terraform, then backend. You have to define the backend name, let's say S3, like this, and then you have to define different, this is different parameters. Let's say for example, the bucket name. So let's say this is my bucket. Then you have to define the region where your bucket is created. So region is equal to, let's say, US East 1. And then if you want to define the encryption, you want to encrypt your state file, you can do it encryption is equal to true, right? And other things. And you have to define the key and the DynamoDB table. So key is where you will be storing the Terraform backend file. So let's say it is stored in my path terraform.tf state file. This is where I will be storing the state file. And then I need to define the DynamoDB table name. So let's say this is my table. So this is where I'll be defining the DynamoDB table. So this I need to create it and I need to create the S3 bucket as well. So this needs to be created first. So this we will see practically how to define the backend. So we have to create a S3 bucket and we have to also create a DynamoDB table like this. And this is how the backend block is defined. So it starts with backend and followed by the custom name. Here you can give any name. So I've just given S3 or you can give S3 backend. Any name you can give. This is anyways custom name like this, and you have to define the remaining parameters. So mostly the important part is you have to mention the S3 name here. Instead of name, it is bucket. You have to define the S3 bucket name, DynamoDB table name, and where you want to store the Terraform state file. So it will automatically create this folder, my path, and inside this Terraform state file will be created. You have to define the bucket region and encryption. In case if you need an encryption, you can define the encryption is equal to true. So this is how backend block is used. So backend block is mostly used to securely store your state file in some remote backend. So rather than storing your state file locally, it will be stored in the remote backend. By default, your state file will be stored locally. So that is the default behavior. Whenever you create Terraform, first it will create a state file locally. After that only you have to make the connections and or you have to do the configuration and you have to store the state file in the remote backend. So you have to create S3 bucket, you have to create DynamoDB table, and then you have to define this Terraform backend block. Then only you will be able to store the state file in the backend, S3 backend, right? So this is how the backend block is defined. Now, as I told you already, S3 bucket is used to store the state file, and DynamoDB table is used to log the state file. So there are two different functions of these two different services. Bucket is used to store the state file. It is just used for a storage purpose, or you can call it as a remote storage. It will be done with the help of S3, AWS S3, and DynamoDB is used to log the state file. so that the state file can only be used by a single user at the same time. So this is called locking the state file. So when multiple users are working in your organization, if you want that this log or this state file should be locked to a single user at the whenever he is working, so that can be done with the help of DynamoDB table. Okay. Moving ahead, let us discuss another important block that is called as a provisioner block. And this is one of the most asked interview question. What are provisioners in Terraform? So this we will be discussing theoretically, and also we will be doing the practical as well, right? Because this is one of the very important block, that is provisioner block. So let me first explain you what is a provisioner block. Provisioners are used to run some scripts after the resources are created. Now let's say you have created an EC2 instance with the help of Terraform code. You have created a simple EC2 instance with the help of a Terraform code. You have written the Terraform code, and with the help of the code you have created an EC2 instance. Okay. Now after the EC2 instance is created, what you want to do is you want to install some scripts inside this EC2 instance. Now you may be thinking, then again I have to go to AWS. You have to get the public IP login, SSH inside the EC2 instance using MobiXterm or any other tools, right? So that is the process that we used to follow, right? So again, I have to get the public IP. I have to log into this EC2 instance and run the script. Instead, there is a way that is called as a provisioner. So rather than manually running the commands, rather than manually running the scripts, with the help of provisioners, you can run the scripts that you wish to that you want to run. Let's say, for example, I want to install HTTP, or let's say I want to update the operating system, or let's say I want to install any package after the EC2 instance is created. This can be achieved with the help of provisioners. Okay. So this provisioner block is defined within the resource block itself. So you have to first write the resource block like this. And so let's say AWS underscore instance, then my EC2, and you will be defining the parameters m equal to me123. Then you will be defining the type equal to p2.micro, and so on. Right? And you will be completing your resource block with a curly braces. So within this resource block is where you have to define the provisioners block, provisioner like this. Then you have to define the provisioner type, remote exec or local exec. So I will explain you what is remote exec, local exec, and then you have to define the um, user equal to, let's say if I'm using Amazon Linux, it will be EC2-user. Then I have to define the public IP. Public IP is equal to AWS underscore instance, AWS underscore instance. I have to get the output of the public IP, my EC2 dot public IP like this. Then I have to define the key, what key I need to use. So let's say I'm using my key.pem. Okay, so these protocols I need to define, and then I need to close this bracket like this. I'm just giving you an example. I will explain you this in more detail later. But this is how provisioners are defined. Now, provisioners are of two types. Okay, so these provisioners are of two types. One is called as a local exec, and the other is called as a remote exec. So local exec is used to run the commands locally within your machine, within your laptop. Then we can use local exec. So let's say you want to give some output. Let's say EC2 instance is created. You want to just show an output in your local laptop, in your laptop. Then you can make use of this local exec. This is just to display some local messages. And remote exec is used to install some packages in your EC2 instance. So this message will be displayed in your laptop. Okay. This will be displayed in your laptop. That is the local exec. Here, let's say you want to install Apache in EC2. Then for that you can use the remote exec. So remote exec is used to run installation script, or let's say it is used to install scripts and all in your remote machine. That is where remote exec is used. And local exec will be used in to display or to run some command in your local machine. So this is my laptop. So that is what local exec means. And the other is the EC2 instance. So the remote exec will be used on top of EC2 instances. So if you want to install some scripts in your EC2 instances, then in that case we will be using remote exec. Right? So that is a difference between local exec and remote exec. Again, this will be asked in interview. What is local exec provisioner, remote exec provisioners? So you should be able to explain them the differences between both. Right? So I'll show you how this, let's say, local exec is written. So you have to write provisioner local exec command equal to echo hello world. So what this will do is it will just display the command hello world in your laptop. So this is an example of local exec. And here I have shown you an example of remote exec. So this one thing you should remember that provisioner will be written within the resource block. Okay. So this is something that you should remember. So this is nested block, you can say. So this is a block within a block. Provisioner block will be written inside the resource block. This is how it is written. This is how we have to define the provisioners. So they will always be defined within the resource block. So this is kind of a nested block, you can say. This is called as a nested block. It has the nest within the resource block like this. Here also it is within the resource block. So that is all about provisioners. So this is the local exec. It is used to run the commands on your local machine. Remote exec is used to run commands on your remote server. Example EC2 instance. And here I have given the note that the provisioners are defined within the resource block. Now moving ahead, let us discuss the another important topic. Again, this will be asked in interview. What is Terraform workspace? So yesterday I had given you a brief overview of what Terraform workspace is. Let us understand this Terraform workspace in more detail. So Terraform workspace is used to is used when you are working with multiple environments in your Terraform. So let's say you are working with multiple environments. You are working with dev environment, UAT environment, SIT environment, staging environment, and production environment. So these are the uh, most used environments in real time. Right? So these three come under non-prod, and these two they usually come under staging comes under pre-prod and prod. So this is the prod. This comes under pre-prod, and this comes under non-prod. This is just for your information. You should be aware of the different environments that are used in real time. So if anybody is working on dev, that means he is working on non-prod environment. If anybody is working on staging, he is working on pre-prod environment. Like before releasing the code to production, This is like creating a similar environment like production and just testing the code. So these are the different environments that we work in real time. Right? Dev, UAT, SIT, then staging and prod. Now, in real time, you will be working with multiple environments, and you cannot use the same or you cannot use the same Terraform code in this or in all the environments. For example, when I'm working with let's say dev environment, I will be using T2.micro because I'm just doing some testing, right? But when it comes to production environment, I cannot use T2 micro. I will be using M5 large, right? I will be using big machines, 32 GB RAM, 64 GB RAM of machines, and this is just 1 GB or 2 GB of RAM. This is a machine. So here the environment is small and the number of users are very less. That is the reason I can that is the reason I can work with T2 micro. But here I cannot work with T2 micro. I need some bigger configuration, like for example M5 large. So in non-prod I can work with T2 micro. Now how to switch or how to just change the instance type and accept changing the other code. So I have written all the code. All the code is fine except the part that I want to change is the T2 micro. So let's say I've written a Terraform code like this. Resource. So I've written the Terraform code like this. Resource AWS underscore instance. Then my EC2. And I have defined some parameters. ME equal to ME12345. Instance type equal to T2.micro. And again some parameters, security group equal to, let's say, my security group, whatever I have defined here. Then I can define the tags. Tag is equal is a set of values. So tag is equal to, open the curly braces, name equal to, let's say, my app, and owner equal to, let's say, my organization. Like this, I will close the tags and I will close the resource block. So let's say I've created a code like this, Terraform code. Now this code, I want to I want to work or I want to use the same code across multiple environments. Same code, except this needs to be changed. Except the T2 instance type needs to be different. Okay, instead of T2 micro, you want to use M5 large. So the code should remain same except for the instance type. Because again I have to write the entire code and that will be quite time consuming. Okay, and I told you already that Terraform is kind of reusable, right? So it follows the reusability, it has reusable modules. So you don't have to waste your time on creating different environments. So instead, you can just switch across these environments with the help of workspace, Terraform workspace. So Terraform workspace is used to work across multiple environments in your organization. Or let's say in your Terraform code, if you want to switch across multiple workspaces, you want to switch across multiple environments, then that can be done with the help of Terraform workspace. And this is kind of similar to what we discussed in Kubernetes namespace. That namespace we had created to isolate the different environments. Likewise, you make use of Terraform workspace to isolate different environments. So whatever changes that you do in this non-prod, this will not be reflected in the prod. Okay, they are completely isolated. They are completely segmented, right? So production will have the different code, or let's say production will have different value. Non-prod will have a different value. You have to just specify which values you want to change. Okay, so that can be done. That can be achieved with the help of Terraform workspace. Now for that we have to run some commands and all. So that we'll be discussing in the practical how to make use of Terraform workspace. But as a high level overview, this is how it is done. Okay, this is how Terraform workspace will come into picture. So it is a feature which allows you to work on multiple environments using a single configuration file. So you don't have to create multiple configuration files. You don't have to create non-prod configuration file, again production configuration file, because that will be kind of a copy paste kind of a job, and that needs to be avoided. Okay, this is Terraform. It has reusability features. We will use that reusability feature of Terraform rather than copying and creating copies of the same configuration file. You can make use of the same config file, but you can just define whatever changes that you want across multiple environments. So multiple environments generally share the same set of configuration. So mostly the configuration is same except for a few things, but different set of resources, variables, and set type. So they can also have different set of variables, different set of resources. Okay, because here I can just variabilize this. Instant type is equal to variable dot instance type. I can variabilize this, right? So the variables will change. Okay. So if you want to switch across multiple features, multiple variables, or multiple environments, for that we will be making use of Terraform Workspace. Now this feature can help us to create different environments for development, production, and staging. So if you're working on dev environments or pre-prod environments or production environments, you can make use of Terraform Workspace. So here I've just given an example that if you want to switch from instance type T2 micro to M4 large or M5 large, you can easily do it with Terraform Workspace. The state file for other workspace will be stored inside terraform.tfstate.d. So this is one thing that you should remember. Then when you are working with multiple workspaces, the state file will be different for different environments, and that state file will be stored with the file name terraform.tfstate.d, right? So this D is for different environments, right? So in real time, we have non-prod environments like dev, asset, UAT, and for production, we have staging and production. So that is what I've defined over here. And now moving ahead, there is another topic which is called as a Terraform Cloud. So this is only from the interview perspective. So uh, we will not be doing a practical for Terraform Cloud. But this is just for the from the interview perspective. In case if they ask you what is a Terraform Cloud, you should be able to answer them. So this is just a graphical user interface to create Terraform infrastructure. So if you're not good with Terraform commands, Terraform has introduced another feature that is called as a Terraform Cloud, wherein you can create all the resources graphically, right? So the models that you have created or the templates that you have created, you can store it in GitHub or any other repository, and you can call it in the Terraform Cloud. So we can just run the commands with a single click. So rather than running the command Terraform apply, Terraform destroy, you can just use the point and click methods to create the Terraform infrastructure. And here Terraform Cloud can also help you to store the sensitive data. Right? So it has a feature like Terraform Vault, wherein you can store sensitive information. Or let's say there are some credentials, username, passwords, or some sensitive information. Then you can make use of feature like Terraform Cloud, Terraform Vault. So these are some features that are provided by Terraform, wherein you can store the sensitive data. So we don't have to worry about storing the state file. Okay, so here there is no concept of storing the state file in S3 bucket and configuring the DynamoDB table. So this is already taken care. In Terraform Cloud, the state file is also taken care. The sensitive data is also taken care, and it uses the point and click method to create the cloud infrastructure. But this is not that popular because most people they prefer using the commands only. Okay, so Terraform commands are only more used mostly. But in case if they ask you in interview what is a Terraform cloud, you should be able to explain them that it is a graphical user interface which is used to create the cloud infrastructure graphically. So you can use the point and click methods to create the Terraform infrastructure. So that's it from my side. Okay, so we have covered the theoretical topics of Terraform. We have covered the important blocks of Terraform. Okay, so just go through these blocks because in the practical we will be using the resource block, data block, locals block, and then provider block, provisioners block, backend block, and input block. Sorry, variable block, output block. So all these blocks we will be using and when we'll be starting the practical. So from tomorrow we'll be starting the practical, and we will be seeing how to make use of these blocks. Okay. So I'm done from my side. If you have any questions, then you can please go ahead and ask your questions, or else we can wrap up for today. Okay, I believe there are no questions. So we'll wrap up for today and we'll connect again tomorrow. Thank you. Thank you, everyone. Okay,
Thank you.
thank you.